Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at the purpose of wide area networks. We'll be discussing LANs and WANs, public and private WANs, WAN topologies, carrier connections, and then finally the evolving network. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. There are several differences between a LAN and a WAN, a local area network and a wide area network. First, we're going to start talking about our local area networks, or a LAN. Now, a LAN typically services a smaller geographical area. Now, what do I mean by a smaller geographical area? Well, it could be something like a branch office. So it could be like a branch office where maybe you have a satellite and you have maybe 10, 15 people working in a different town in a smaller office. It could be this telecommuter. They're working on their home network, and that's a local area network. Or a LAN could be maybe a room in a building. So maybe it's over here in your big corporate building. It could be a room. It could be a floor. However you want to break it up, that makes sense, but it's typically smaller than like a city or a country. Another thing about the LAN is they're used to interconnect different computers, peripherals, and other devices on that network, so everybody in that one geographical area can connect to them. And so you're looking at a geographical area used to interconnect these closely connected devices. A LAN is typically organized and managed by the organization or the home user if you're doing this at home. Normally, if it's a local area network, that company controls that network. They're able to log into the system. They're able to make changes without having to go to a service provider. Another thing about a LAN is there's typically the infrastructure cost, where we're looking at purchasing the routers, the switches, the cabling, the access points, however you're making your local area network run, but there's no additional cost after that. Well, except for electricity, but there's no monthly fee you have to pay. LANs typically provide high-speed network or high-speed connectivity to those devices. Nowadays, gig to the desktop is not uncommon in a lot of companies. They have gig to the desktop. Backbones and data centers are at least 10 gigs nowadays. And we see that these higher speeds are traditionally on LAN networks. Now, let's talk about this compared to a WAN. WANs normally provide service over larger geographical regions. Now, it could be maybe it's your entire building. It could be maybe a city, a state, a country. It's typically a much bigger area than your local area networks. The other thing is WANs typically interconnect remote users. That would be the telecommuter and the person working from Starbucks. They interconnect different networks, and WANs typically interconnect different sites. That would be the branch office, the remote site, to your enterprise network. This is where WANs usually fit in, is between two LANs. They interconnect those LANs together. Now, WANs are typically managed and owned by some sort of service provider. Typically internet service providers nowadays, but it could be a telephone service provider, cable service provider, or even a satellite service provider. You don't own the equipment. You don't manage it. You don't set it up. You don't do the configurations. You contact your service provider every time you need a change or there's a problem. WANs typically are provided for a fee. You pay your internet service provider a monthly fee. You pay the people that run your telephone lines, your cable lines, the satellites, you pay them a monthly fee. That typically describes your wide area network connection. WAN speeds are usually slower than LAN speeds. So your wide area network connections are usually slower because they have to go over longer distances. And a lot of times as that signal travels over longer distances, it degrades a little as it goes through the medium. And because of the signal degradation, they either have to repeat the data or send it slower. And so those are typically smaller. And now I say they usually do. With some of the newer technologies nowadays, these WAN connections, a lot of times, are fairly capable of reaching the same speeds of our LAN connections, our local area network connections. But the key thing here is your WAN connections are usually going over those longer distances. Instead of LANs, typically you're looking at a couple hundred feet usually. WANs, you're looking at miles, if not tens of miles, sometimes up hundreds of miles, depending upon exactly what technology you're using. The line between LANs and WANs used to be fairly straightforward. One of the big key things here to pay attention to is who controls it. Who can log in and make changes to those devices? Who gets the phone call when there's a problem with that technology? If you and your company get that phone call, it's probably a local area network because you can log into it, you can control it. But when that phone call comes in and it has to go to a service provider, it's probably a WAN technology. There are two classifications you can give a wide area network. One is a private WAN and one is a public WAN. That private WAN, there's some benefits there of that. You get a guaranteed service level. And what we mean by a guaranteed service level is you're guaranteed a certain amount of speed and a certain amount of uptime. Of course, you're probably going to pay more for this. And with that speed, you're also looking at a constant bandwidth. That's what you're going to get guaranteed here in that service level agreement, is this consistent bandwidth. And because this is a private wide area network, a lot of people consider it more secure because you're the only one on that wide area network. Now, a public wide area network is typically something provided by an ISP. That private network that we first talked about, dedicated to one customer, you have lease lines and you're the only one using it. With a public a public wide area network, it's provided by an ISP or a telecommunications server, and you're going to share those networks with other people. You're going to share that. And more often than not, it's over the internet. Private doesn't go over the internet typically. Public typically goes over the internet. Now, once again, I'm saying typically because there's always exceptions to these rules, but that public WAN, you're going to go over the internet. And because you're going over the internet, everybody else that's on the internet may have access to your data. And so that's why we use a lot of encryption and point-to-point technologies when we're talking about these public WANs. Service level agreements and bandwidth, they're going to vary by the contractor, your provider. And you can get very high levels of service and bandwidth, but you're going to pay more than the average person. And they don't guarantee security because other people are on there. Other people can see your traffic. As we look at WAN topologies, there's several different ways you can organize them and you can create your wide area networks. Here we have 5 of the most common ones: point-to-point, hub and spoke, dual home, full mesh, and then partially mesh. And how you set up your network is what is right for your company. Now, a lot of times the answer may even be a combination of a couple of these, especially in larger networks, you're going to see these combined. First one we're going to talk about here is a point-to-point topology. This is for your wide area network. This is typically between two sites, a site A, a site B, and there is just one connection between them. There's no other traffic in that connection. There is no other way to have somebody else get traffic onto that. This employs a point-to-point circuit between two different endpoints. It involves a layer 2 service through a service provider. So you have to go to a service provider. They may give you a lease line or whatever you come up with, but you have to go to a service provider. And then that point-to-point connection is transparent to the customer. And so once you have that set up, this point-to-point connection, the end user isn't going to notice this. A lot of times in this point-to-point technology, we have this cloud, and you can see we drew this cloud around here. This cloud sort of represents the internet. And what this roughly estimates is you send in data in one side here from site A, that data comes out here. Now, how does it get across the internet? I'll be honest with you. From this point of view, you necessarily don't care if data goes up and travels to New York, then Philly, and then down to your site B, or it comes in and goes to Chicago, to Kansas City, and then to your site. As long as data goes in one side, comes out the other, that's what you're concerned with. You're not going to concern what your internet provider does right here. And this is where your provider comes in. Your provider comes in here and they're responsible for getting that data through. Because it's their responsibility, you're just concerned with setting up the connection to one side of this point-to-point and the other side, and however that data makes it through, as long as it makes it through according to your service level agreement, that's a good thing. Next one we have here is a hub and spoke technology. What this does is it enables a single interface on this hub router right here. So a single interface to be shared by what we call the spokes on this. And so it's one interface here that's going to connect to 3 different routers in this example. And if you would draw this sort of in a circular, that hub, that center router is the center, and then all the other devices connect into it. Now, these spoke routers out here, these out here on the edge, they can be interconnected through the hub using virtual circuits. So we can use virtual circuits here. Virtual circuits. And routed sub interfaces. So we create some sub interfaces, but we can make these connections here. And the spokes only communicate with each other through the hub. So if spoke A wanted to talk to spoke B, and when we're talking spokes here, this could be, I mean, your hub here could be in Chicago, and this could be New York and LA here. Now, if New York wanted to talk to LA, they have to go through Chicago and back to LA. They can't make that direct connection right here. The downfall of this, if there's a problem in Chicago and this router goes down, basically your entire wide area network is now shut down because all traffic typically travels through the hub. And because there is no hub, that wheel doesn't work anymore. That center is gone, so the wheel doesn't work. That hub and spoke does not work. Next topology is a dual homed. So we're going to take that hub and spoke and we're going to add in some redundancy. Notice here we have 2 hubs. We have hub A here and hub B. They function just like normal hubs, but you have redundant connections. They both have a connection to the internet. So they have their own connection there. So if one of these goes down, it still is up. And then hub A has got a connection to all 3 of your spokes. Hub B also has that, so we have redundancy. If one of these connections goes down, if the connection here on hub A goes down here at point 1, if it goes down here on point 2, or even if it goes down on point 3 here, there still is a redundant connection through hub B to make those to make the connections so the communications over your wide area network still function. Now, this offers enhanced network redundancy. It gives you load balancing, distributed computing and processing, and the ability to implement some backup. But it's more expensive because you now have 2 hubs, because you have the additional network connection if you're using it. it's more difficult to implement because we require the additional configurations in making sure everything is right with the redundancy. As you set up your connections, you want some redundancy, but what level of redundancy do you want? We could either have a fully meshed network or a partially meshed network. Here in a fully meshed network, you have 4 routers. And each of these 4 routers has a connection to every other router. So site A has 3 connections, 1 to B, 1 to C, 1 to D. And if you look at site B, they have those connections going back to each one of the routers. So they all have a connection. If one of these connections goes down, data can still make it to site D by going to site B and then on the site D or down to site C and back up. It can make that. You could even lose a second connection here. And site A could still talk with site B, but the path it would have to take is going from site A to C to D to B. Or it could go from C to A. And you can see that we have this fully redundant connection, that if one of these connections goes down, they're all there. And once again, we're using these multiple virtual circuits to connect all the sites. Each site has a connection to all the other sites. Downside, very expensive because you need a lot of connections. If you add in a site E, so let's add in a site E, all of a sudden we go from 1, 2, 3, 4, 5, 6 connections with the 4 sites. We add in that 5th site, we have 6 connections. This gives us 7, 8, 9, 10. And all of a sudden we have 10 connections, and it keeps going up and up. So at some point, you're not going to have a full mesh on your network. Imagine if you had 20 devices on your net, or 20 sites you're interconnecting. You wouldn't want a full mesh with everybody connecting to everybody, because that's over 100 different connections you have to manage and pay for. What we typically get into at that point is a partial mesh. You have to sit down in your company and figure out which are our most important sites, where do we need that redundancy, and where do we not need that redundancy. And here, we can probably say site A down here on this one is our headquarters. And then we have our two offices here on West Coast and East Coast. So those are our 2 main offices, and then site D here is in the Midwest, where if Midwest goes down, East Coast and West Coast can probably handle it. It's maybe not as big as an office, maybe doesn't have all the people and the resources as the East Coast and West Coast. But if West Coast goes down, then that whole third of the country is going to have a problem. And this is maybe where your biggest customer bases are. And so you have to decide which is the most important sites in your company. Make sure you have the redundancy there, and then not have the redundancy in some place where you can afford that if this site goes down for some reason, if Midwest, the connection between HQ and Midwest goes down, your company can survive that. If you like this episode on the purpose of wide area networks and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. As we talk about these WAN connections, a lot of times you're going through a provider, and these providers, typically we call this carrier connections, how you connect to your service provider, your carrier. Now, what we think about when we look at these carrier connections is what we call the SLA. You'll hear a lot of people talking about, well, what does your SLA include? This service level agreement gives expectations that you're going to have a certain bandwidth, typically, is what we see here. We also see that you have a typical uptime. Now, uptime is usually represented in a percent. We would like an uptime of 99%. That's That's an acceptable uptime. Once again, depending upon your business. And so you have to decide for your business. Sometimes we hear 5 nines of uptime. That is 99.999% uptime. If you translate the 99.999, the 5 nines of uptime, so 5 nines, the downtime per year is approximately 5 minutes. So that equals approximately 5 minutes per year. Now, to get a downtime of 5 minutes per year, you're going to pay a lot more for this 5 nines than just 99% of the time. Looking at our uptime once again, 99% is about 3.5 days of downtime. So that gives you about 3.5 days of downtime. 99.999% is 5 minutes. Now, these service level agreements, and they definitely can vary, but to get this five minutes of uptime, you're going to pay about 5 times as much dollars as you would compared to the 99%. And so you're going to pay a lot more. And oftentimes this is also going to require a bigger expenditure on equipment. You're going to have redundant equipment around. And so this service level agreement is one thing you have to think about when you're looking at how you're going to connect to your carrier. How important is that uptime? Can my company survive being down a couple hours if my internet goes down? And a lot of times the service level agreement here will include the response time. So I'll put response time here. How quick are you going to get a response to your problem? Is it less than an hour? Less than 4 hours? Within a business day? So a business day. How can your company relate to that? If your company doesn't rely on the big network connection all the time, maybe you're smaller, maybe you're not as IT intensive today, you could maybe go with the within 4-hour response time or within a business day. But if your data is really important, you want that less than an hour response time. And of course, the shorter that response time, the more it's going to cost you. Then this carrier connection, this SLA, it outlines the expected services relating to the reliability and availability. That's what we're talking about up here with all these bandwidth, uptime, and response time. The service provider may or may not be the actual carrier. That's another thing to look at. Because of how licensing and the FCC and different federal regulations have played out, that your service provider may not actually be the one actually carrying the data, because of how they have to share services and provide equal opportunity for different service providers, the people who actually own the equipment. Your service provider may not own the equipment. So that's another good thing to look and ask for is, do you actually own the equipment? Do you actually provide that physical connection? Or are you just basically reselling a service? That's always good to know. When we're talking about these connections from your company into another site or into the internet, there's two ways you can kind of look at it. You can look at it like a single carrier, and this is the single up here. And then you can look at it like a dual carrier. Now, in a single carrier, you're going to contact one company. Your SLA is going to be negotiated with one organization between you and your provider. In a dual carrier connection, what you're going to have is basically 2 separate SLAs. You're going to go in there, you're going to negotiate what you want in your SLA, what levels of service, how much you're going to pay, but you're going to negotiate it with each one of the providers. So they're going to be separate providers. You're going to have 2 different SLAs with 2 different providers. Now, it's going to give you the redundancy, but of course, then you're probably going to have to pay twice as much because you have 2 connections. As your company grows, as it evolves, so do your networking requirements. Now, they may be very simple and changes in your network requirements, that you went from 100 users to 120 users. Maybe it's very drastic. You've acquired 3 different companies and you went from 1,000 users to 10,000 users. All of a sudden you have to support this. And so each company is going to have their own different processes and growing pains for an evolving network, but you kind of got to go through the same process here for all of them. So each network has to meet the day-to-day operational. So how do we get our employees in our company to do their job, to make money, so that way we stay in business? So you need to make sure that those day-to-day activities, think about all your office workers, your shop workers, all those people need the connectivity to do their job. Then you, as a designer or an administrator, you have to meet the challenges here, and you're going to have to choose a whole bunch of different things. You're going to need to look at the different technologies and protocols and even different service providers, what they all have to offer to help your employees do their jobs. Now, we can do optimization. And depending upon how we go into designing your network, how we're setting it up, we can use a whole list of different techniques. We can use a whole list of different architectures. Now, to talk about this, what we're going to do in the next couple slides here is I'm going to show you some examples of a company that is growing. The company starts out small. Maybe you have a small office, handful of employees. Maybe you're even working out of a garage in your house. But you're not going to really want to set up a whole big network. You're not going to want to incur the cost of buying all these routers and switches. You don't need that. And so what you're going to do is you're going to go out and contact your local internet service provider. It's a DSL, a digital subscriber line, a cable modem. You're going to get that connection coming into your office. And we have the internet. We have this connection coming into your modem here. It should be broadband access, not dial-up, but a broadband. So like I said, cable modem, DSL. Even in today's world with the newer satellite technology, satellite could be an example here. And that would be enough to supply your users, handful of users, handful of devices on your network with the network they need. This router here is a wireless router. This is that $100 router, DHCP server, NAT, PAT server that you can buy from a big box store. That's what your network kind of consists of. Here is a modem. A lot of times you get that from your internet service provider, and then this $100. And yeah, it could go anywhere from $50 to $300. But it's that all-in-one device, DHCP server, DNS server. It has a small switch on the back of it so you can hardwire a couple devices in. All those in that one package. Where if you have more than 20 users, it's not going to be sufficient anymore. But right now for your small office, this is it. Now, if you have a problem with your internet connection, you contact your provider. And that provider will most likely be able to help you because it's a very simple network. And that's all you need at this point in time. Within the next couple of years, your business has grown and it's done extremely well. You went from a handful of employees up to maybe 100 employees, and your network needed to evolve. What we see here is that maybe each area of your company or each floor has its own local area network. That's what these yellow circles are, is these are all LANs here. And so we have 3 different LANs, local area networks. They all have their devices on them. They have PCs, printers, laptops. They have access points in there. They have switches. Each floor, each place has their own router for this local area network. And so you have 3 of these all connected into a core router down here. This could be a core router, or it could be a firewall to protect your network. And so all of a sudden you are working in this building. You're at hundreds of users. You're being protected by a firewall or a core router. This provider here for internet is no longer a simple cable modem or DSL. You have contacted a service provider that will give you a business grade internet connection. And so we've seen it grow from a small office to maybe a building, a whole building your company now takes in. And the other growth that's happened, instead of calling up your provider for IT support, maybe you have some IT support in-house. And those in-house people are responsible for anything on your network, whether it's one of your devices that failed to connect, to the routing between the different local area networks, to the configuration of your firewall. You have now hired IT staff to work those. And this network is called a campus network, or a campus area network, a CAN. And it's because you have maybe different parts. You have the different areas that are all connected together by one core router. It allows us to have those multiple local area networks sort of in one area. Then, after a couple more years, your company has enjoyed a lot more success. You have definitely grown, and you've outgrown your shoes. You've outgrown your campus network in your building. And so we have what we typically refer to as the central office, or your main office, your headquarters. Let's say that's in New York. Your company is growing up and has filled that building. You now have to have a second building. So let's create a branch office here. This will be New York 2. It's another building right here in New York, but your original building is too small, and so you had to get a second building. So we've now created a branch office here. Eventually, we're going to start looking at, okay, let's go ahead and create a remote office. That remote office could be in a different city. And so this remote office could be, I don't know, let's say in Miami. This remote office then gives you the ability to have people sort of down in the southeastern part of the country versus just in New York. So now you're spreading out and you're able to cover more territory because your customer base is growing. And maybe it's growing so well that now instead of just the East Coast, we have to look at putting a regional office over here in LA. And now you've started looking at getting this big coverage of the United States here to say, okay, we have set this up, and this is typically what we call a metropolitan area network, a MAN, M-A-N. This metropolitan network, when we connect up our buildings and our sites, we use the internet. Once again, this cloud represents the internet. And so our connections coming in here is here. And you probably may have private dedicated lines that have to go to a service provider, but you have these private dedicated connections that go to all of your locations. And so this metropolitan area network is connecting all of your devices, and your company has grown, and you wanted to have coverage throughout the United States. Once again, you're going to a service provider. Now your IT department has grown a lot. You no longer have a handful of IT people that do everything. Now your company is big enough where you can hire IT that specializes in certain areas. Maybe your WAN connections. And so the interconnectivity between all of your remote buildings. You have a team that handles that. You have a team that handles all your local area network connections and the IP addressing and the design. And you have another team where it's the help desk. And so you start seeing your IT specialize in areas because your company is big enough to handle that. And finally, at your 20-year anniversary of your company, you have gone international. Your company has had such success. We are now an international company. And so this network is growing. You now have thousands of employees. They're all around the world, making your company successful. And so you still have your headquarters, your central office here in New York. You have some branch offices, Miami, Washington, or in LA, to follow from my last example. We have those. But now we even have regional offices in South America, in Africa. You have to now support telecommuters, that maybe you have a salesperson here, and this would be like a salesperson, over here in London, and they have to connect in. And so this telecommuter is going to use typically what we call VPNs to get into the network to have these secure communications. And your company has a huge IT staff at this point in time. They're maintaining all aspects of your network. You're employing all sorts of different technologies to make this work, to make your company successful. It was my pleasure to provide you with this wonderful episode on the purpose of wide area networks. If you like this episode and got value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.